Hi, this is Dr. Otto Janke with the Empire Longevity Podcast. I'll be honest, I'm not quite sure where this one's going to go, folks. I got to tell you the truth. We wanted to find someone to talk about the cosmos, the longevity of the cosmos. If we're going to talk about your next best decades, we need to talk about the thing or things that's been around the longest, which is the cosmos. It's the universe. So we brought in, I want to call her the space lady from now on. We brought in Zoe Ponterio from Cornell. We're going to talk about all the cool stuff that happens there. But Zoe, thank you for being with us today.
Well, thank you for having me, Otto. It's a pleasure.
It is fantastic. First of all, how'd you get into space and all that thinking? I mean, that's just the coolest thing.
Well, I think it started very early as a little kid, watching astronauts in the space shuttle and just seeing how they floated around. And everyone, you have that dream of flying. And in my little kid head, that was like, oh, that's how you do that. And right there was born the seed of like, well, I should become an astronaut. And I think that then built into understanding, space and everything out there. And I think the next thing that really happened for me was in 6th grade, I got selected as one of 3 students from my school. I grew up in Southern California, to go to the Jet Propulsion Laboratory in 1989 for the huge press conference releasing the first ever Voyager 2 images of Neptune, this planet that we'd never seen up close, and sitting there in the auditorium and kind of realizing that the whole world was going to get to see this, but I was still among those first people to be staring at pictures of this totally other world other than Earth, and seeing that there are people doing this. There are people who were exploring space, not just astronauts, but people working on these robotic spacecraft going out. And that was a real big of like, oh, there's more to it than just going and floating around in space. And then again, being close to JPL was great because I got to go back in high school and participate in a little design competition you had 3 days to furiously come up with a space station orbiting Mars, and got to see, I graduated high school in '96. So when I was out there, they were finishing building the Pathfinder mission to Mars with the first ever Mars rover Sojourner. So I had that closeness to it. And also there's a bit of a deeper family history there, in that I also grew up knowing that my grandmother had worked on a component that ended up going onto the Apollo mission, the lunar rover that the astronauts drove. So there was always just this idea of like space seemed rather obvious as an interest. And that's why I think I decided when I got to college that I had to keep pursuing that. And I think at one point my mom kind of said, well, astronomy, what are you going to do with that? Fast forward to the point where I get into grad school at Cornell, and Dr. Steve Squires invites me to come be on the Mars Exploration Rover Spirit and Opportunity mission. And she kind of had to admit, like, oh, you're going to do that with it. And I said, yes, I'm going to go work on Mars rovers. And that's awesome. Sort of how it got to the point of being an actual professional space explorer.
When was the first time you looked up and you went like, well, that's cool?
I think the stars, of course, are not easy to see when you're in Southern California. So growing up, I think I had an idea, oh, there were the stars out there, but I didn't spend a lot of time out there looking at the sky itself. But we had these books, I remember, back in the day when there was no internet. And so you had, World Book Encyclopedia.
There was a time when there was without an internet?
Right, yeah. And my mom had got these books on space, and one of them was just all about the planets and contained a lot of the Voyager images, at least the ones we had at that time, and how I would just keep poring over those books. And I think the thing that really caught me was I would just read the facts and figures about the other planets over and over and over again, just trying to comprehend that there were places that were worlds, though, that were completely different than Earth, but also similar, but just looking at the temperature differences, the gravity differences, what the air was like. And I just couldn't get over that idea of other worlds, that there was more out there than just what I saw around me. And it wasn't until I spent some time in darker sky conditions looking through telescopes that I started to realize that this wasn't just something in a book, that, these were the first time I saw like a planet through a telescope. You looked at Jupiter and saw that it was a disk, not a point, and you saw the moons. The first time you see Saturn's rings through a telescope, and you have this feeling of, oh my gosh, it's not just a picture in a book. I'm looking at it with my own eyes.
Right.
And then again, seeing like the results of spacecraft going out there, it became something more than just a book and maybe even a fiction. It became a reality.
How cool is that?
It was pretty awesome. Yeah, I wish I'd grown up in a place where I could see stars better. But yeah, that was not actually what started it all.
That's absolutely fantastic. That's absolutely cool. So you must have been fantastic in the sciences in school.
Yeah, science is always good, but honestly, my shining subject, and probably, to some extent still my favorite subject, is math. I just always loved it, always had it come pretty easily. So a lot of times when I struggled with science, the concepts, as long as it was something like physics or chemistry, I could like kind of fall back on the math and kind of get my mind around it that way. So yeah, I mean, other subjects were pretty difficult, especially sciences that didn't have a lot of math behind them. I was not a strong reader, and like history was my worst subject. I did not have a good memory for things like that. So, and I wanted to lean into those strengths and just kind of shrug and say, okay, so I'm good in math and science, sciences that have math behind them. You don't have to be good in everything. Unfortunately, or fortunately, I will say, my mother was an English teacher. And so there was no saying, sorry, I'm just not good at reading and writing. And she really took me under her wing. And because of her, I can read fairly well, but more importantly, she taught me to write. And she taught me to write very well. And I use that, of course, now constantly in my work. And so forever grateful that she would not let me get away with just saying I'm good at math. Isn't that enough?
Isn't that enough? Isn't that enough? A couple points for you. First of all, what color hair do we have now?
I'm currently sort of taking a break from fun colors. This is sort of close to my natural color. I am gonna go back to some pink in the near future, I think. If you look back at my hair, I love to have fun with it. My hair is one of those things that I've changed so many times. I have been super short, I have been super long, different colors. It's just a way that I can kind of express myself at any given time and never let anything hold me back.
Zoe, I'm all about it. I'm all about it. You should have seen me last week. It was incredible. Let's dive into some cosmos. How old is the universe? Do we have an idea?
Current estimates put it, I think, around the 13.8, 13.7 right there, billion years old.
How do we know that?
Let's see here. There's a couple of different ways that you can look at this. One of them is to simply observe how things are moving right now.
Right.
That's the one I think people hear the most often, the expansion of the universe, and that if you then just run the clock backward, everything just gets more and more dense and leads to a point in time where you essentially have infinite density. Now, whether that was actually the case or that's even possible, nobody knows. Unfortunately, our current understanding of physics can only tell us down to like right before that, right after that happened. But so that's one of the ways, is just running the motions that we see in the universe backward. But there are a few other ways in which we can measure that. For one, we can observe how far away we can see, right? Light has a finite speed to it. And so if we keep on looking farther and farther and we notice that, well, we don't seem to see anything beyond 13.8 billion light years away, wow. Doesn't mean there's nothing out there. It just means that possibly the universe has not been around long enough for things farther away from that for their light to have reached us. So the fact that there seems to be this bubble around us of a visible universe, and that, of course, as we look farther out, we're looking back in time because we're seeing light that left that object long, long ago just reaching us. So we can also look at it observationally as we seem to be in this visible bubble where looking out, we're seeing older. Now, another way that I don't think it's talked about enough is the idea of chemicals. The chemistry of the universe does change. Stars are nuclear fusion factories, and they take, for most of their life, they take hydrogen and they fuse it into helium. And then as they continue to age, they fuse that into heavier and heavier elements. And so that means that with each generation of stars, the universe gets more diverse in its chemistry. It's still mostly hydrogen, and the second most abundant is helium, the two lightest elements. But the reason that we're able to have things like planets and our bodies is because of stars. Carl Sagan was not kidding when he said we're made of stardust. Like about over 90% of your body was created in a star. And so you can also kind of run that clock backward and realize that that's a process that's been happening, and that when the universe first started, it's about 3/4 hydrogen and 1/4 helium, maybe a little bit of lithium, which is the next one. But that was how things started. So you can also run the chemistry backward in time to see, like, when do you run to a point when there wouldn't have been any of these heavier elements, because the universe is still mostly those lighter elements. So things that make up our bodies and the Earth and planets are tiny fractions of what the universe is made of. And what I find fascinating is that we haven't always known that. And there was a time where we thought that the sun and stars were made of the same thing as the Earth, because we just said, well, there's nothing special about Earth. Everything must be made of that. And of course, it was, the famous, but unfortunately not famous astronomer Cecilia Payne, who discovered that the sun and also then most of the universe was hydrogen, and was actually told, no, that's crazy, and don't publish that. No one will ever take you seriously. She did. And she, people are like, I haven't read her name in an astronomy book or any book. How can I not have heard of the person who discovered what the universe was made of?
Right.
So I always tell her story anytime I get a chance. So there's several of these clocks that we can just run backward to show that the universe definitely has not been around forever, definitely had some sort of birth time. And to a certain extent, it can be hard to decide what that looked like, but it definitely shows that one of the big ways Einstein was wrong is there was a time where he subscribed to the steady state theorem, that the universe was kind of just always around and always would be around, and nothing was changing very much. And when Hubble discovered the acceleration of the expansion, and not the acceleration, but the expansion of the universe, he had to admit, like, oh, okay, yeah, I was wrong. The universe definitely evolving, is changing, and appears to have had a starting point.
So why didn't we hear about Payne?
Sexism.
Yeah, she's female.
She was a woman.
Yep.
I can sum it up with that word pretty much.
You're absolutely. 2 points for you. One is I one time met Carl Sagan.
Yeah, like I said, I'm sorry to say that I came to Cornell too late to have ever met him, but I do have colleagues and friends who worked with him, so I do get to kind of vicariously hear what it was like to be around him.
I sat next to him, and this was decades ago, of course. I sat next to him at the expanses of the Ithaca Airport one time, and this was when it's small now. It was tiny then, and I sat next to him and I gave him a hey, because you hear his voice, you know exactly who it is. Second question: are we the only universe?
Ooh, tricky. The word universe. yeah, the hard ones here.
Why is that a tricky question?
The word universe in itself was an attempt to create a word that meant like everything in existence.
Yeah.
And as I said, as far as what we can see with light, basically the definition of the universe is everything that we can observe. But the idea of multiverses is a really interesting concept. And it's something, of course, we have no direct evidence of.
Right.
But it is the question of, who's to say that this, whatever the birth of our universe was, who's to say that's the only time that's ever happened? Why couldn't this have been something that's happened a lot of times?
Right.
And to say time is weird because, of course, the birth of our universe created our space-time. So that's already kind of hard to wrap your mind around. But then there's also this concept, if you are a Marvel fan like me, of the multiverse being these infinite possible realities that are created by every choice that we make, that maybe those other choices are still some other reality. So the term multiverse has a meaning kind of in science fiction of multiple realities and multiple possible timelines, but it has also a real thing that's being talked about in astrophysics, the idea of maybe our universe, what we call the universe, is not the only such, reality, and that this is something. And they actually, it's not that it's impossible to look for this. There are actually people looking for evidence of this. The idea being that if there are other universes, maybe we've bumped into them. And actually looking back to what is the edge of the visible universe, the cosmic microwave background, basically the glow left over from this Big Bang that started the universe. And they're looking for maybe patches in it that could indicate a collision with another universe. I don't know if this is anything that we'll ever be able to say, like, yes, definitely there are. But the important thing is that people are thinking about it and actually trying to find some sort of evidence for it.
That's spectacular, isn't it?
Yeah, it really boggles the mind that it can maybe detect other realities by looking for places where they've bumped into our own.
My question has always been that, I know we're gonna get way off on this, but my question has always been that, aren't we looking for what we would think would be carbon-based lives? And therefore there might be other massive amounts of other life forms that we just don't look for because we anticipate they're going to have 2 or 4 legs or something like that, and they could be all around us all the time. It's just that we are so human focused that we don't realize that there's other planets, other universes, other stuff going on that we don't have the technology to find them also.
Well, I think that one of the things I love about the time period of my life is that I have gotten to see us go from the question of, is this the only planetary system? Like planets around, we know there's planets here, we live on one, but are there planets around other stars? Get to go from that to saying, are there any stars that don't have planets? Because that's where we're at now. And just realizing that the first planet was discovered in 1992, as I said, I mean, I was starting high school in that year, and it took a while before we got to the point now we know thousands of planets. And to actually see that through my adult life, see that question flip on its head. And I don't think anyone was terribly surprised that planets are common, but it's one thing to think that something makes sense, another thing to find evidence of it. As we just saw, everyone thought the sun was made of the same stuff as the Earth, and that made sense until somebody found out that wasn't true. So now we do know that, yes, there are planets around stars are a common thing. We already know of over 4,000 of them, and that's just in our little neighborhood of the galaxy. And of course, there are hundreds of billions of galaxies. So we know that planets are plentiful. And if you've ever looked at the Drake equation, we're slowly filling in some of those unknown numbers that would predict how prevalent intelligent technological life actually is. And if you don't know about the Drake equation, you should tune in tomorrow at 3:30 to the Copernic Observatory YouTube channel. I'm doing an Astrofest talk for them on this issue of where are the aliens and what is the Drake equation. So I'll plug that. That's going to be a fun thing. I don't know if this is going to go live before that, but the point is, you can view it once it happens. You can go to their YouTube channel anytime. They keep everything there. It's not just for live broadcasts. So Copernic Observatory, there will be a talk as part of their Astrofest 2021 that includes me talking about this issue of where are aliens. And I tell you, especially when I go and talk to kids, at some point the Q&A will get, and I won't say derailed because it's a good thing, it'll get suddenly taken over the minute someone either brings up aliens or black holes. One of those two, and then you know that every question is going to be about that. And aliens actually happens more than anything else. And so it's something that I do love to talk about. I don't know if you saw my YouTube channel. I did a Minute in Space episode trying to say like, okay, this is where we are. And it's an interesting thing to look at with from someone with a math background. I look at the statistics of trying to imagine how vast the universe is and saying like, I just don't see how it could be statistically possible that we're the only life, and probably not even the only intelligent technological life. The thing that you then run into if you study astrophysics is that pesky speed of light thing. And one of the things that you discover, it is because as fast as it seems to go around the Earth 7.5 times a second, which is what light can do, once you start talking about cosmic scales, it starts to seem incredibly slow. It takes 8 minutes just for light to get from the sun to Earth. It takes 4.5 years for it to get to the next star over. It takes 100,000 years for it to go across the Milky Way galaxy. And suddenly you start to realize, like, if there truly is no way to break the light speed barrier, then this really puts a hindrance on being able to travel or even communicate. We struggle to communicate with spacecraft that are exploring the solar system. Voyager 1 is the farthest man-made object from Earth, farthest spacecraft from Earth, and it takes over 21 hours to get a signal to it. And this becomes a challenge for, I mean, having worked on a Mars mission, you have to deal with this lag. You can't control this rover in real time because there's anywhere from a 4 to 20-minute lag of waiting for light to get there with your message to the rover.
So I guess the question then would be, so we're going to rule out, we're not going to totally rule out, but we can kind of put to bed the idea that someone is going to be coming to us from planets or systems away. We're kind of putting that.
I think that it's not impossible. I mean, I could see a civilization doing something where they sent probes out, knowing that those probes would travel for millions of years, and by the time someone picked up on them, they would be long gone. I could see someone doing that, but again, the vastness and the chance of one of those probes actually intersecting any planet, you know, our own, is so incredibly rare. And one of the things that, is rather sad is looking at how empty space actually is. And you know, communication, I think, is something that we hope for. Actual visitation by some sort of craft seems, you know, unless someone's figured out how to exceed light speed, which no one is saying we'll never figure that out, but it's something that we don't know if it can be overcome. And if it can't, then the chances of actually traveling between civilizations is, you know, pretty much impossible. So, but yeah, the talking to, right? SETI is a thing that we're trying to see if we can receive signals, even if they weren't directed at us. Maybe like we're sending out random radio signals all the time. So we're looking for that sort of signature, maybe not so much a message sent specifically to us, but just the noise from some other technological civilization.
So is it because our imagination isn't big enough, or because our mathematics can't prove it well enough that therefore we don't think it can happen?
I think it's something that we acknowledge, that we don't know how to overcome that barrier right now. And I hope that no scientist would say, therefore we can't, because there's been so many points in the past where, you know, we have said, oh, this is just something that can't be done, and then it turns out that they find a way that can. And I've watched this happen in my own lifetime when I was in college. So not too long ago, we're talking less, you know, 20-ish plus years ago, I knew some professors of mine in astronomy that confidently told me that based on the way telescopes work, there'd be no way we could ever directly take a picture of a planet around another star. We have those now. We figured out a clever way to work around the obstacle that they were citing. So it's something we can't say never, but we also have to be, we can't overwhelm ourselves with optimism either. We also have to be prepared for the possibility that this is something that at least no intelligent life has figured out how to get around. Again, even if we've got other alien civilizations and none of them have figured it out, doesn't mean it can't be done, but it might be something that is just either impossible or just too incredibly difficult to overcome. So I think that a lot of the focus, I mean, we're looking for life on multiple fronts, right? We've got the passive listening of SETI. We've got the probing of exoplanets, planets around other stars, letting the starlight pass through their atmospheres and seeing what chemistry is there. And then there's also still exploring our planetary system, exploring the solar system, and realizing that though we're pretty sure we've ruled out other technological life, we would have found its signatures by now. We still are actively, in fact, have just started actively looking for life of any kind in our own little neighborhood right here. So while we still only know of one example of life here on Earth, which makes it pretty difficult to say anything intelligent about the nature of life in general, we are at least taking those baby steps, hoping to return these samples from Mars that we just had our first successful collection of a sample to return to Earth, going to Jupiter's moon Europa and trying to find out about its subsurface ocean. Same with Saturn's moon Enceladus, also with the subsurface ocean. Those oceans seem like they could have conditions very similar to our deep oceans. And then you go out to Saturn's moon Titan, which has lakes of liquid methane, and you start to ask, what if there's life that uses liquid methane instead of liquid water? And you look at Venus, maybe Venus once did have life, and maybe some evolved type of it is still surviving, floating in the clouds. And so we acknowledge the fact that, with one data point of life, we have to keep an open mind. At the same time, you still have to narrow and actually look for something. Acknowledging the fact that not finding that, it's the problem of lack of evidence isn't evidence of absence. But we have to start somewhere. And so you start with what you know. And so we're starting with looking for water-based, carbon-based life with the full knowledge that, we're not saying this is the only way life can happen.
Well, we'd hope not, but with as diverse as even our galaxy is. The next question that has to be asked is, if there is alien life form out there, do you think they have as cool of music as we do, having sent Chuck Berry out to space? I mean, that is because if an alien life form does not have cool music, then do we want to hang out with them?
I love music. I was brought up on music. I have musicians in my family, so I definitely identify with that sentiment of the thought of being able to hear some other intelligent being's idea of music, or would they even have a concept of music? It is a very interesting question. I look at the fact that when we were sending out this golden record on the Voyager spacecraft, which of course Sagan was very involved in, and when you're deciding, like, what do you even put on this thing? And that a big chunk of it is taken up of music. And I actually, this is what I love about working where I work, is you never know who's going to wander in. And one time a few years ago, I saw these people out in the hall, and I'm like, hey, can I help you? And they were like, yeah, we're looking for, they were actually looking for the Carl Sagan Institute. But I was like, well, why don't you come into Spiff? Let's see if I can show you some cool stuff there. They turned out to be filmmakers from the country of Georgia who were doing a film about one of the songs that Sagan selected to be on that golden record. And it was a traditional Georgian song that originally they were told they couldn't put on the record because at that time, of course, the Soviet Union said, no, you can't put that. You will put this song. And they defied them, and they put the Georgian folk song on the record. And they were doing this film. But and of course, I knew about none of this. I was fascinated to learn about this. I went and listened to the song, and just seeing the whole story behind that, how it was music as defiance and protest. And watching how that's now sent out into space, and maybe someday somebody will find it, figure out how to listen to it, and maybe they won't understand what it is, but it's out there. And those golden records will last for millions of years. And so even after all of this is long gone, they'll still be out there. And so, the idea of something like music or mathematics and things that we take as universal to humanity, but what would that look like in an alien culture? So yeah, if they didn't have music, I would definitely want to be the one to introduce them to the concept. But yes, that would just be so amazing, especially if we found they did. If we found they did and found that to be some sort of commonality that beings shared, this concept of music, because of course we're not the only animals on Earth that make music. So yeah, it's just a fascinating thing. I'm going to think about that for a long time now.
All right. I think taking an alien to like an AC/DC concert might be, I don't know if that'd be a deal breaker or like, oh man, now we're in. Let's talk about SPIF for a second.
Sure.
What is it and how cool is it?
So it is, SPIF is short for Spacecraft Planetary Image Facility, and we began 41 years ago. And we were part of what was known as the Regional Planetary Image Facility Network. That actually no longer exists, but a lot of those facilities still continue on, Cornell's being one of them. We started as a place, again, pre-internet, where people could go to get photographs, images, and data that had been obtained by spacecraft.
So they'd actually go to Cornell to get it.
They would actually go to Cornell or one of these other facilities. And so we still maintain an archive of a lot of these negatives and prints from missions like Voyager, Viking, Magellan. We still have all of those, which now becomes sort of like a museum because of now all these images are available digitally online. So we still now do help people to access the digital products that have been converted. And we also will run workshops and provide technical assistance to people who are trying to analyze those images. So we do a lot with mapping. We use a lot of GIS software, except instead of doing like GPS on Earth and finding an address, you're mapping another planet. So we do a lot of that, and a lot of that software is designed with Earth in mind. So I have to teach people how you can use it on worlds that aren't Earth. And then we do a lot of outreach. And this is something that has just been a big part of SPIF since its inception. The idea that we need to go out and talk to people, visit schools, connect both people like me that are professional educators and communicators, but also the scientists doing the research, and get them all connected so that we get to share this all with the public. And so for me, SPIF almost mirrors my own journey to being the manager of SPIF, in that I started out as a scientist who thought they would do research. And I started out working on, the rover mission and being a part of that spacecraft team and being part of obtaining the data and analyzing the data. But then what happened was when they would come and ask for volunteers to go out and do these outreach events, I would just throw up my hand right away, like, yeah, that sounds fun, I'll go. And there's a lot of scientists that, they're like, no, I want to sit here and analyze my data. And yet I just wanted to go out there and talk to people about it. And
Sure.
I started to do this more and more, traveled the country actually on a tour called Marsapalooza that NASA put on. Yes, Marsapalooza, we were rock stars, literally rock stars.
Oh.
Yeah, I still have my band
the flag on the
jacket
play.
and everything. So we did that, and it was amazing. We lived like rock stars. I mean, like airport to airport, hotel to hotel, event to event.
That's cool.
And that was so much fun. And I eventually decided, I think I like, as much as I love like doing research, I was like, the idea of taking that and going out and sharing that with people who are not scientists,
Right.
I loved that even more. And come to find out, people kept on saying, wow, you're really good at this. And so I ended up turning away from a research job and actually went into teaching, and I taught high school math and physics for 10 years. And then I heard about this job opening up. The person who had this job before me, Rick Klein, had been here for over 30 years. I had known him when I was a graduate student at Cornell, and I heard he was retiring, and my thought was, there's just the perfect job because I
Perfect.
am a scientist. I have the experience of doing research, working on a spacecraft mission team. At the same time, I now have 10 years of being an educator, and I've got all that experience of being a, public outreach and communicator. And this job allows me to put all of that together and be able to do what I feel I both love most and also am best at. So I feel like I am doing the best thing I can do to contribute to the scientific community and, to the public at large.
And bless you for that, and that you actually have that opportunity, because many people never get that opportunity. How can people contact you about that, and is it open to the public?
So normally, yes, normally SPIF is a public facility, and we would accept both scheduled tours, but also walk-ins. We would have normal public hours that anyone could just wander in.
Not so much
that
fun.
was a really fun part of the job. Like I said, not knowing who's gonna just pop in to say hi. So almost like a very small museum and outreach center. We would host field trips from schools, and then also take the show on the road. I would go visit schools. I'd go to the New York State Fair every year and hang out at a booth in the 4-H building. And, so it's a lot of that. Right now, unfortunately, we are still closed to the public as far as walk-ins. We are looking at hopefully later in the fall starting to schedule tours for individuals, small groups, single household families to come and have a little tour. And I'm doing a lot of this, obviously, for a year and a half now. I have been on Zoom talking to classrooms. My whole family knows when I'm doing one of these, especially with little kids, because I have done kindergartners over Zoom, and the level of energy you have to engage them over Zoom is so much more than you need doing it in person. And I definitely do miss the in-person part. I cannot wait to get back to that because just interacting with people, kids to all ages, is just my favorite part of the whole job. So
are people able to contact and that online?
Okay, yes. So getting back to the how to contact us. So we have a website, cornellspiff.com. You can send a message. There's a contact us tab, so you can send a message through that website. Our email is spiff@astro.cornell.edu, so that email goes to me directly. We also have a Facebook page, so if you're on Facebook, you can find us there. As you mentioned, we have a YouTube channel.
Yes.
And so these are all ways in which you can reach out to us. We do also provide a website that's a companion to the Ithaca Sagan Planet Walk that the Science Center created, which is one of the few full-scale models of the solar system where both distances and sizes are represented accurately.
Yes.
We helped work on the plaques. A few years ago, new plaques went up on the monuments, and I helped a lot with that. But then I also run the website, and the nice thing about running a website version of it, of course, is every month, in fact, I'm doing this right now because it's still the start of another month, I get to put fresh news articles on the website, which is saganplanetwalk.com. And so it becomes this virtual way that has an advantage over the physical walk in that you can't go and slap new articles on the plaques every time something new is discovered, but I can go to the website every month and put one or even like 5 or 6 news articles for each of the locations in the solar system so that it's a living thing that can be updated regularly. So that is also a great place to go if you are looking to stay up to date on the happenings, especially if you're not on Facebook. Just kind of go into that site once a month and seeing, okay, what's new, what's happened is a really great resource.
How cool is that?
It also keeps me up to date. Like every month I get to sit there on Google News search, poring over it for new articles. And so what I don't hear through the grapevines of my colleagues' work, I oftentimes hear about things like that I then share, and they're like, I haven't heard of that. I'm like, well, I have to spend time poring over and hunting down all this stuff, and it keeps me up to date on all those discoveries as well.
That's the cool stuff. That's the cool stuff. Zoe Ponterio. Fantastic. The space lady Zoe is with us, and next time we have to have you, and we got to have you in full spacesuit. I mean, and maybe in zero gravity too. How great would that be?
That would be awesome. I mean, the best I can do today is I've got a NASA shirt on. That's the best I can find.
That's pretty close. Zoe, I told you about this before. This is going to be our last question for you today, in that the definition of longevity we've had in Empire Longevity is that the act and intent of being so healthy that you leave something great behind by what you've done today. What's that thing you're going to leave behind? What's the dent you're going to leave in the universe?
I really hope that I can, especially in working with children, but ultimately people of all ages, to help to understand, like, why do we explore space beyond just it's cool? And the fact that exploring space benefits humanity in a multitude of ways. I say, like, how can we possibly expect to understand the Earth as a planet if it's the only planet we ever study? That makes absolutely no sense. You need to do comparative planetology. That's how science works. And so being able to get out there and make sure that space exploration continues, that people don't start to cast it off as thinking it's not relevant, to continue to make it relevant. And especially when I go out to visit kids, to help them see that anybody can work in space exploration. And I do actually a video about this, the idea that you don't even need to be a scientist or an engineer, that it takes every kind of person you can possibly imagine to do this. And if you think space is cool, that's your only prerequisite. And you can come and bring whatever it is you've got, art, music, you're a lawyer, we need space lawyers. Yes, that's a thing. So being able to get us the best possible workforce to continue this exploration of space. And so I just hope that I can take my ability to communicate and educate, and that I can make sure I have left the next generation and generations to come with the best possible group of people to do this and to accomplish that, which in turn will come back to Earth and make things better for everyone. Learning about climates and other planets, we can figure out ways to be more sustainable to our own climate. Learning about discovering another form of life could have massive implications for medical advances right here on Earth. And so just hoping that, yes, I can continue this idea that exploring space is something that is not some abstract science fiction thing that you do for fun. I mean, that is kind of what it is for some of us, but that it's much bigger than that. And so, my little small sphere of influence, I hope just can ripple out, and that I can make that little bit of difference of, passing on my passion and excitement for it to other people, and making sure that this is not something that we cast aside as not relevant and not helpful and not important.
How cool is all that?
I think it's pretty cool.
How about the first space chiropractor? Have we talked about that yet? Because I think I'm up for it.
Medical things. Think about the astronauts on the space station right now. They can't call a doctor for a house call or go to a hospital. And so astronauts, you have a crew of 5 or 6, and they all have to have a basic medical training. All have to be versed in those. And as we explore, it's like we're eventually going to, if we're going to have like a colony on the moon, you're going to have more than, as I said, more than just scientists and engineers are going to be necessary to make that happen. And learning about what weightlessness does to the body, what lunar gravity does to the body. Muscular skeletal systems tend to not like you changing gravity on them. So figuring out ways around that is huge.
I just want to let you know that I'm ready to go anytime you need me. I have a bag. I have a bag packed just in case. I just want to let you know that it's an overnight bag, and so I think I'm pretty good for any kind of space travel.
I would love a chance. Like I said, at the very least, I would love someday to do the vomit comet, just to feel what weightlessness feels like. But if I was offered a chance to do one of these space tourism things and just be in space for a few minutes, I think I would totally do that. When I was younger, people, when I was working on the Mars rovers, people would ask me well, would you go to Mars if you were offered that chance? And when I was in my 20s and single, I was like, yeah, in a heartbeat, I'd go. Now I'm in my 40s and I have a family, I have kids. It's now kind of a weird, I don't know that I'd want to, but at the same time, it's like, oh my gosh, but the chances. So my perspective has changed quite a bit
That
on
happens.
would I go there or not? So
That happens.
like I said, the best I can do is hopefully, maybe some kid that I talk to in a school some point will grow up to be that person who goes to Mars. So,
and we never know. Zoe, so glad you could take the time out, be with us today. I appreciate your insights, your love, your expertise, and your energy you bring to this. And I hope we can communicate many more times in the future.
I hope so as well. This has been great and a lot of
fun. Zoe Ponterio, sorry about that, Ponterio from Cornell. She is Space Lady Zoe, which you got to have your own cartoon coming up sometime soon. I mean, I'm surprised you guys don't have that, because you guys have reached so many people to be incredible. I appreciate your time and expertise and love, and we'll be in contact soon. Thank you so much.
All right. Thank you, Otto.